All right, guys, are there any questions over the homework? No. Now, what we're doing today is probably going to be as short of a lesson, or might be a little bit longer than yesterday, because what we're talking about is function operations, composite functions, addition, subtraction, multiplication. So as we talk about function operations, we're talking f plus g of x, or g plus f of x, or f minus g of x, f times g of x, or f divided by g of x. And really, we can consider it or break it up into the two here, the two parts of the function, because sometimes this will be written as f plus g of x, which is just the same as saying f of x plus g of x. We're just adding the two functions together. And the same thing is true with subtraction or multiplication or quotient. We're multiplying, dividing, or subtracting. And the easiest one out of these is normally quotient, because as long as there's not something in common on top and bottom, we don't have to do anything to it. The domain of arithmetic combinations of a function f and g consists of all the real numbers that are common to both the domains of f and g. In the case of quotient, there is further restrictions that g cannot be 0, because since g of x is in the denominator, we're dividing by it. Anything that would make it be 0 is going to be a restriction. So we have the sum, the difference, the product, and the quotient. And again, we've covered this before, because we did this in Algebra 2. So given this, we want to find f plus g of x and then evaluate it when the sum is 3. Well, so we can say f plus g of x, which is really just saying that we're taking f of x and adding to it g of x. Well, f of x in our case is 2x plus 1. And g of x is x squared plus 2x minus 1. Now we're really just going to combine like terms, because there's no negatives, no subtractions. We don't have to worry about changing any of the signs. So we can just combine like terms. Well, we only have 1x squared. But we do have 2x and 2x, which gives us plus 4x. And 1 plus negative 1 is 0. So f plus g of x is the function x squared plus 4x. And that's what we get. Questions on this here? Yes, sir. I have one on my desk. So we found f plus g of x. Now we just need to evaluate it when x is 3. So it's just plugging in 3 for x, yes? And for us here, well, that's just taking 3 squared plus 4 times 3. 3 squared is 9, 4 times 3 is 12, so this here is 21. And I mean, we could have plugged that in a calculator and it would have told us, because we could do 3 squared plus 4 times 3 in a calculator and gotten our answer. Now, again, we do need to be careful when we square a number, because if what we're squaring is negative, it's going to come out as positive, yes? Now, again, this is not something I normally cover in the Algebra 2 class. It's more of just a kind of side note. Personally, when I type something into the calculator, because if we'd have said evaluated this for negative 3, so negative 3 squared plus 4 times negative 3. Or we can do this with the quadratic formula. If I were to type this into the calculator, I'll pull the calculator up, we know that negative 3 squared is going to become what? Positive, yes? So when I type it in as 3 squared plus 4 times negative 3. Because I could put that 3 in parentheses and have it be negative, but I know it's going to come out positive, yes? So we could do it this way. I could still put it as negative 3 squared plus 4 times. We'll still get the same answer. I'll do the same thing, especially with the quadratic formula, because inside the square root, it's b squared minus 4ac. I'll just put the value of b without the negative, because it's not going to make a difference. But that's just a side note. Any questions on this here? I think we're kind of used to these so far with these kind of function operations. Composite functions are one that we do cover, especially in Algebra 2. I remember going over it in high school, and we called it fog and Goff. Because when we write this out, f of g of x, one way that we can write it is f o g of x. Okay. So we have this here, f of g of x. And we call this, or the reason I say fog and Goff is because f of g of x, the way that this is written, looks like fog. Well, the other way we can have it is g of f of x. And with any of these here, we work from the inside out. So f of g of x, so we'll do g of x first. Now, since it's just x inside the parentheses, we just replace it with g of x. Now we have f of x plus 1. So I'm going to replace the x in f of x with x plus 1 and get x plus 1 squared. Now, if we wanted to simplify it from here, we could just say that this is x squared plus 2x plus 1. We're just multiplying x plus 1 by itself. But questions with this here? Now we can look at two of these here. We'll look at these three here, and really, I have a feeling that that's almost pretty much it for the slides. Now we look at f of g of x, the first one. So we have f of g of x. Now f of x. We start off with the center, so g of x. Now what is g of x? 4 minus x squared. Now since we're just talking about g of x, realistically what we're doing is we're replacing x with x. It's not changing. So we still have 4 minus x squared. Now we need to evaluate f of 4 minus x squared. Well, this time we replaced x with 4 minus x squared. So that means this, any x in the function has to be replaced with 4 minus x squared. So what we'll have is 4 minus x squared plus 2. Questions on this here? Now we can drop the parentheses and combine like terms. Well, we'll still have negative x squared, but we have 4 plus 2, which is plus. So f of g of x is negative x squared plus 6. Questions on this here? I don't know why I didn't group those two, but it did not. Now we can go the other way around, g of f of x. Well, let's say we have g parentheses f of x. And this is going to work almost the exact same, except instead of taking g of x first, we're taking f of x first. And our f of x function is, bless you, x plus 2. Well, now we have g of x plus 2, which means I'm replacing every x in g of x with x plus 2. So we'd have 4 minus x plus 2 squared. Now here, if we evaluate this, 4 minus, well, x plus 2 squared is saying what? We're taking x plus 2 and multiplying it by itself, yes? And if we wrote this out and did the whole multiplication process, we would end up getting to x squared plus 4x plus 4. And again, I am not expecting you to know these just off the top of your head. This is mainly from doing these kind of multiplications way too long, and I just know what they're turning out to be. Because again, like I said, write them out if you need to write them out. Doing them in your head only increases the likelihood that an error will occur. But the last thing we need to do is we need to distribute the negative through. So we would have negative x squared minus 4x minus 4. And when we combine like terms, we'll get negative x squared minus 4x, because the 4 and negative 4 become 0. And we get this here. Any questions on any of this here? Are you ready for the last one? G of f of 2. Negative 2. G of f of negative 2. Now there's two ways that we could go about this. One of them is I would work from the inside out. If I hadn't actually gotten G of f of negative 2, or G of f of 2, I would work this from the inside out. Nope, didn't get him, but he did decide to draw on the board. These flies are annoying. Now, did we already find G of f of x? Well, yes. So we could use it to actually solve this. We could say this is negative 2 squared minus 4 times negative 2. And at this point here, we can type the whole thing in the calculator and be done. Negative 2 squared is 4. Negative 4 times negative 2 is plus 8. And negative 4 plus 8 is 4. And that'd be our answer. Now, if they didn't actually ask us to find G of f of x first, we just asked for G of f of 2, negative 2, I would work this from the inside out. So the first thing it's asking for is f of negative 2, yes? So I'm going to plug negative 2 into f of x, which would be negative 2 plus 2. Well, what is negative 2 plus 2? It is 0, yes? So we have G of 0. So that means I'm going to plug 0 into G of x, which would be 4 minus 0 squared, which is indeed just 4. So even as complicated as these get when we're evaluating from a number, we just work from the inside out and simplify as we go. But that's it. Any other questions on this or the root interrupter? So that's it. That's all we're going to look at with this here.